Okay, we're recording. Good morning, everyone. Just as a quick reminder, as I always do, you get the email notice. Everyone that's here in the webinar received one of these. There's a link to Dennis's email if anyone has any questions about upcoming webinars or any technical issues. Clicking on the link that is in your notice takes you to our webpage, the Safety Academy site. Lets you know the topics and the dates of upcoming webinars. And more importantly, there's also a document library here that has the PowerPoint presentations. The one for today is already on there, and the recordings of the past webinars. And this goes back to 2013 when we started doing this. In addition to that, there's resources at the bottom, including a PDH request form for professional engineers that need education. You'll notice also as handouts in the GoToWebinar that the PowerPoint, the PDF presentation, as well as that PDH request form, is included on there for a direct download right from GoToWebinar. With that, I'll turn it over to Dennis for his formal intro.
Okay. You gonna let me share my screen?
Yes.
Okay. Good morning. I'm Dennis Falloon, and I'm the District 7 Safety Academy Coordinator and Consultant. And I want to welcome you to the 5th webinar for the District 7 Safety Academy for 2016. Today's webinar topic is roadway safety, guardrail safety for designer, and guardrail safety for installers. And today's presenters are Richard Stepp and Durwood Shepard, and they're from the FDOT Roadway Design Office in Tallahassee, and they're both professional engineers. Richard has a degree in civil engineering. He's got 9 years of experience developing roadway and structure details, including 6 years of experience developing DOT design standards and design software, and is currently the design standards engineer. And Durwood is currently the design standards publication manager and technical expert on roadside safety design. He also is a civil engineer, and he's got his master's, undergraduate degree from FSU and a master's from UF, University of Florida. With that, I'm going to start with my introduction before I let the presenters present their topic. As I mentioned, you're presently attending the District 7 Safety Academy, and this academy was put in place to provide information to local agencies to enhance their local agency safety programs. It began this year, the 4th year of the academy, on January 6, 2016. The webinars are usually on a Wednesday, and they run from 10 a.m. to 12 p.m. That's our slot, but they usually run between an hour and a half. As you will see here, I've got an ending date of December 14, 2016, but in actuality, in November, we will have 12 webinars, and we may still go with a 13th one on December 14th, but that's still an open option. And as Anthony mentioned, there is a registration link on the page you showed previously, and also going to the Tampa Bay Traffic Safety Academy webinar page. This is the workshop series. These are all the dates. Today's webinar is roadside safety, guardrail safety for designer, and guardrail safety for installers. And you'll see the other various topics that will be coming on up. And then also notice on October 19th, we've got a new one, Innovative at-Grade Intersection Designs. And that'll be put on by FHWA. Wanted to mention also that information is being submitted for AICP CM credit for those that are certified planners. And then also wanted to mention to you too the topic of applying safety data and analysis to performance-based transportation planning. Also, FHWA is pending and will be scheduled in one of these 3 dates that are open. And I will let everybody know about that when that time happens. Also, if you want, as a professional engineer, PDHs, you can follow these instructions, and they're out on the Safety Academy webpage. You get your credit, 1 PDH. And if you need any additional information, you can contact me by email or give me a call. And with that, I want to turn it over to Richard and Durwood.
Okay, let us just get control of the screen here. All right.
Richard, I failed to ask during our little pregame show while we were talking about space, but if the audience has questions, would you like them sort of throughout the presentation, or do you just want to maintain your train of thought and hold questions till the end?
I think what we can do, I see the chat capability here. If there's questions, they can type them in, and this is broken up into 4 parts. And so we can stop at the end of each part and then kind of talk through some questions and maybe backtrack a little bit. You know, we realize we're going a little bit, I guess they call it high level on this one, just to give a broad overview. So there is a lot of potential for many questions on the nitty-gritty details, you know, and that's not really the intent here. But yeah, in general, we can go through and kind of sort through some of these questions that people have, and they can type them in, and then we'll get them at the end of each part, like I said.
Okay, perfect. Yeah, I'll keep myself muted, and then at the end of each part, we'll check in and see the chat to see if we have questions.
Okay. Let me just pop this up. Okay, so everybody can see my screen now? We're good?
Yes.
Okay. All right, very good. Okay, so I appreciate the introduction. Been working with Dennis and Anthony in the last few days to set this up, and they did a good job. They kind of recruited us to, it was a good opportunity for us to spread the word about Guardrail even more. Currently, we've been out giving training in Guardrail in every district. That went out, the announcement through our contact mailer probably 5 or 6 months ago. A lot of people registered for that, and we've been visiting each individual district auditorium and giving an all-day training. Those trainings are about 7-8 hours long, and they're obviously more comprehensive, meant for designers. What we plan to do today is kind of condense that a little bit. This training will probably be about an hour and a half. Is our goal is to end this by about 11:30 or maybe a little closer to noon, and just basically give you guys an overview of how Guardrail design works in general, and just kind of put all the ideas in your head and give you information on where to find more information, so that if you're interested, you have a general idea of how Guardrail design works, and then you can go and find more information about it. Additionally, we have upcoming training. Essentially, we're going to take our training that we've been delivering to every district and make a webinar out of it. It'll likely be 6 hours and be posted online at our DOT website. And at the end of this training, I'll give you information on where to find the more extensive training. In addition to that, we're giving a condensed version at the upcoming Design Expo. I think that's in June in Daytona. And we're doing 2 sessions there, about an hour each. And one of them will be looking at the new Design Standard Index for Guardrail. The other one will be looking at some of the design software we developed. And so that's another place to get a little bit more information about Guardrail. Let me pass it off to Durwood. He can introduce himself real quickly. And then I'll walk you guys through a few of the introductory slides, but I'll just let Durwood say hello.
Okay. Yeah, Durwood Shepard here. Like Richard said, this training is somewhat condensed from what we're doing in the districts. Will be available online at a later date that he'll go through. But you know, we put a lot of work into making some heavy revisions to the indexes and our design policy, which we'll overview today. But yeah, this is kind of a broad stroke at it. I'm sure a lot of people will have maybe some detailed questions that may be outside of the scope of what we're presenting today, but we'll try to get to those as much as possible.
Yeah, if engineers have questions that are more detailed in nature, and we're not able to get to them today, here are our email addresses. And so you can just go ahead and email things directly to us, and we're kind of here as your resource, and we're trying to provide support for this this type of index. So, okay, so there it is, Durwood Shepard and Richard Stepp. That might be a good opportunity to jot those phone numbers down. All right, so as we were trying to tell you, we're going to give you the guardrail crash course. And so here's our guardrail crash course, literally. So moving on. So yeah, Dura was saying we did a complete restructuring project recently on Index 400, and we'll get into some of the reasons a little bit later. But this just kind of tells you what's involved here. We have a brand new index. It's completely redrawn. We made things to scale, kind of an intuitive sequence. It's a lot easier to find information than it was in the past. It's a lot easier to pick up Guardrail if you're a beginner and kind of understand how it all fits together. That was our goal, was to increase kind of the user friendliness. Along with that comes new specifications. We have a thing called new instructions for design standards. The way we explain the IDS as we use them for our FDOT projects is the PPM has designer information, but anytime you have information that's kind of specific for a design standard and that a designer and engineer needs to know to put in his plan so that the standard could work successfully for a contractor, that type of thing goes in the IDS, and we'll show you how to find those coming up. We're going to touch on each of these subjects a little bit more in depth. We have a new length of need design program in Excel. Here's a little snapshot in the lower right-hand corner of kind of the idea of length of need. Basically, it's telling you how long your guardrail has to be designed to shield this hazard successfully. In the past, we've had a really kind of simplified process, and it had been really overly conservative in a lot of cases, and in some cases, it wasn't providing enough length. So we really need to step up to the latest national standards of AASHTO and design guardrail to the optimum length that's the most efficient. So in order to do that, we made a little Excel spreadsheet that kind of helps designers through it and simplifies the process. We revised the PPM, the Plans Preparation Manual, Chapter 2 and Chapter 4, and that's really, Durwood did a great job of consolidating. Anything roadside safety related is now in Chapter 4, so it's all in the same location. You don't have to flip through all the chapters to find what you're looking for. And Durwood is going to speak on that in our next session. And then modifications for the existing indexes for compatibility. So some of the other standard indexes had to change, to go along with the modification Index 400. And once again, I want to point out that our training, this is a kind of a consolidated version of our larger training. And basically, what we're trying to do, we realize that a lot of our listeners right now, some of them, I was told, are design engineers. Some of them have sort of a bigger picture on things, but our goal is to just go through kind of a broad overview, and it can be helpful for engineers because at least they'll be aware of what's new and know where to find information about it if they need to go more into detail. And if you're not an engineer, well, then just having a broad overview, maybe you can ignore some of the details, but you just get a feel and see the pictures of how it all fits together and how it works in general. And so that's kind of what we're going for, is to strike a balance so that everybody can get a little something out of the course. And with that, we're moving into part 1. And essentially, this is all about how to choose to use Guardrail, and then where is it located if you do decide to use Guardrail. And these types of things are found in what we call our Plans Preparation Manual. And I can hand it over to Durwood.
All right. Thanks, Richard. So when we started looking at making a lot of these big revisions to Design Standard Index 400 for our guardrail, we tried to take a step back and evaluate what parts of the current index really belonged in a Design Standard Index, what parts were criteria, what parts were specification language. So like Richard mentioned about all those changes we made as a result of this had to do with kind of dissecting Index 400 and putting things where they belonged. And as we took a step back and looked at where we were going to put the criteria that was previously contained within the old Design Standard Index 400 for guardrail, we realized a larger need for revisions for Chapter 4 of the PPM in general, which covers roadside safety design. So we made a major renovation, so to speak, redevelopment of Chapter 4. A lot of that had to do with, like I say, precipitated by the Index 400, but once we got in there, we realized a lot of opportunities to consolidate information from various chapters and make it a lot easier for engineers and people who are trying to follow all the different criteria that's relating to roadside safety, put it all in one place. This slide is just kind of to provide a link for some people who may have been familiar with the old Chapter 4 of the PPM and now look at it today in the 2016 version and go and question maybe where some of the old information got moved to or where it came from. So if you look back at the implementation letter that went out in Roadway Design Bulletin 15-16 from FDOT, pages 3 through 6 have a pretty detailed outline of all the major changes to Chapter 4. So if you ever kind of get in there and are curious where something moved to or where it came from, this is a good resource for evaluating that and trying to help you put the pieces together if you need to. Again, this redevelopment or reorganization was a large part of it was a consolidation effort, and as you can see here, there was a lot of chapters in the old PPM that covered roadside elements, whether that be lateral offset or clear zone criteria, and so we consolidated all this information from chapters 2, 7, 10, 21, 25, and try to all locate this in one central location. And on top of that, try to make the chapter a little bit more comprehensive and cover all of the roadside elements from clear zone concept to what constitutes a hazard to what barrier options do I have, what are the DOT standard barrier options, what are the limitations and that are associated with it. So, we try to add a lot of new sections here to shore up maybe some of the areas that were being confusing or weren't really covered in our criteria previously. Also, what we tried to do was provide the link that was needed between the state's policies and criteria on roadside design and then where the AASHTO Roadside Design Guide plays a part in that. And the AASHTO Roadside Design Guide is kind of the controlling document for roadside design. It's kind of like the Green Book or the LRFD manual for structures design. This is the kind of national document that houses a lot of the more broad criteria and design guidelines for roadside safety. So we're not rewriting the roadside design guide within PPM Chapter 4, but we are providing those links where people need to understand the value of that document and where the information comes from. Like I said, adding some of these new sections to make it more comprehensive. One thing I wanted to start out with too was kind of just defining what we mean by roadside safety design and where we kind of draw the limits. This isn't based off of an AASHTO definition, but basically if you're familiar with the old Chapter 2 and Chapter 4s, we're trying to give you a better idea of what information is included where. So basically if you're outside of the shoulder on a flush shoulder road or including the curb in an urban environment, everything outside of these is now located in Chapter 4. So roadside slope criteria, barriers, curbs, but your shoulder width requirements for different types of facilities is still included in Chapter 2. So just trying to let people understand where we kind of drew the line between what information went into Chapter 4. For the kind of going through some of the updates that we made, we're not going to cover every PPM update that occurred throughout here, but try to highlight the issues surrounding Guardrail, and primarily one of those being the clear zone concept, which was highlighted in the previous Chapter 4, but one of the things that we wanted to make it clear of is the difference between what is the basic clear zone concept and what was previously shown in Chapter 4, the PPM, which was an adjusted clear zone. So basically, our general requirement for establishing when you might consider shielding, which could be Guardrail, would be if you can't meet this basic clear zone concept, that's when you start getting an indicator that you need to start maybe looking at what sort of shielding might be needed. A part of the efforts in the new Chapter 4 was to consolidate information like I talked about. So where previously the clear zone width requirements were included in chapters 2, 21, and 25, and were referred to as recoverable terrain. We've moved all that information to chapter 4. We've consolidated it for new construction, TDLC, which was chapter 21, and the triple R requirements down here at the bottom. So all of the clear zone widths are located in one place, and we're calling it, what it is, the clear zone width, instead of kind of confusing terms between our criteria and what you would find in the roadside design guide. Another part of that consolidation was lateral offset criteria. Lateral offset criteria wasn't even covered in chapter 4 previously, so we consolidated all of this from those various chapters. And we're really talking about, what are the exceptions to the clear zone when you're in urban areas. So, these are allowances for those devices or objects that are located along the roadside in an urban area that are needed for the normal operation of that roadway. So we have these minimum lateral offset distances that provide allowable offsets for those devices. Moving on to roadside hazards, so we're really starting to define, what constitutes a hazard along the roadside that could be located within that clear zone distance that would start providing the threshold for when barrier might be needed. Previously, the definition for an above ground hazard was located in chapter 10, but we moved that over here. We're basically talking about any object that is within that clear zone distance that is 4 inches in height or more, and is firm and unyielding, or doesn't meet breakaway criteria. I kind of get that question a lot about whether breakaway devices are considered hazards, and as long as it meets breakaway criteria, we don't consider it to be a hazard. So we're talking about fixed objects 4 inches in height or greater. That does exclude curbs. We don't consider those to be above ground hazards. Some of the other kind of predefined hazards that we include within our criteria, one of those is referred to as canal hazards. We didn't really significantly change how we define these in these updates. The only thing we tried to do was simplify some of the verbiage for the offset criteria for canal hazards, and that was basically just kind of bulleting these different definitions for different facility types, whether it be flush shoulder or urban curb and gutter. Before, this was kind of written into paragraph form, and it was kind of hard to dissect out exactly what the different thresholds were, so we just kind of bulleted those items to make it easier to follow. The real revision happened when it relates to, okay, I've met the requirements for a canal hazard, where would I provide the shielding for that canal hazard? And previously, the criteria provided a specific offset from the front slopes of the canal hazard where the barrier might be placed. And what we noticed was that in some cases, because of that kind of strict interpretation of those placement requirements, that other potential hazards were being left unshielded between the roadway and the barrier. So essentially we're saying, instead of prescribing a specific offset, we're saying locate the barrier as far from the travel way as practical, outside the clear zone when possible, but no closer than these set distances that we provided previously. So again, just trying to provide a little bit of a latitude in the design process there. We've seen some locations where by following the letter of the criteria, there were trees and other hazards located between the roadway and the barrier, and that wasn't the intent. The other roadside hazard that's defined within our criteria is drop-off hazards. Not a lot changed here except for specifically adding vertical face structures. Those obviously don't meet traversability requirements per clear zone. So we're just trying to make that clear. We did add in the drop-offs and work zone information from Chapter 10. That's another area where we consolidated information in general, was also including all of the roadside safety information dealing with temporary work zones. but then also adding in an additional hazard consideration section that covers kind of the areas where maybe you need to provide a barrier for reasons other than the protection of the motorist. So we're talking about maybe peer protection, where a structure might be sacrificed if it gets impacted, or where we're trying to protect residential buildings or schools or things of that nature. So we did add in a section there to kind of clue in engineers or designers when they need to be considering barriers, that may be hazardous for persons other than the motorist. A part of the making it a more comprehensive chapter was adding in this section 4.4.1 that covers all of the standard longitudinal barrier options, starting with flexible barrier, which wasn't previously covered within our criteria, which is our high tension cable barrier, our semi-rigid barriers, which is our guardrails that we're going to talk about more detail here today. That includes our kind of bell cow 31-inch system with mid-span splices, so we're kind of defining that within the criteria now. We're defining what the minimum installation lengths should be. Also, the modified tri-beam guardrail, which is still part of our standard. One thing I will highlight is that as a standard longitudinal barrier option, FDOT has removed tri-beam guardrail as a standard run. You'll still see tri-beam panels used in bridge transitions or as our metal traffic railing on bridges like we use for retrofits, but as a standard run of roadside guardrail, tri-beam will no longer be an option. I guess I'll take the opportunity right now to kind of mention that a lot of the changes when we went to the 31-inch guardrail system in 2014 with the mid-span splices, that was kind of a evolution, if you will, in crash testing standards for all roadside hardware. It kind of started with guardrail, but historically we've always used a document referred to as NCHRP 350, which outlined the requirements for testing of different roadside barriers, whether that be guardrail or concrete barrier or crash cushions or end terminals. But what that did was establish minimum vehicle sizes, speeds, impact angles, and we have more recently moved in the direction of a new AASHTO document referred to as MASH, which is the Manual for Assessing Safety Hardware, which has actually been around since 2009, so it's not all that new, but it's now being mandated for implementation in states' design standards and the products that they make available on their approved products list. So, like I said, guardrail was one of the first ones to start being tested to MASH, and as a result of the MASH testing that was done with the slightly larger vehicles and larger impact angles, we found that the guardrail needed to be installed a little bit higher to be able to successfully contain and redirect specifically, what's that?
I'm going to show them pictures.
Okay. Right. To contain the larger pickup truck that's required in MASH, but also the mid-span splice was kind of an evolution of, because of that impact energy increasing, the potential for penetrations of the rail were occurring because the splices were located on a post. That created a higher shear location through the bolting location, so putting the mid-span splice at that location puts that bolted connection in pure shear instead of in pure tension instead of in shear, and it allows it to contain and redirect a larger vehicle. The other part of that is slightly raising the post, and which is why we see increased deflection. So when we went to the 31-inch system in the mid-span splices, we went from an allowable deflection space of 4 feet for our old system to 5 feet for our new system, is because to be able to contain and redirect a larger vehicle, you needed to allow more flexibility into the system, so therefore a little bit higher deflection. So just trying to give a little bit of background information on why we made those changes. When Richard starts going through the actual index later, you'll see some of those changes and how it looks specifically. The other parts of this section were added to cover some of the other rigid barrier or temporary barrier options. We're not going to cover those in real detail here because we really wanted to stick to guardrail. So when we're talking about selecting different barrier options, we added in this new roadway barrier type selection chart. It was kind of to help provide designers a little bit better information on how each barrier type or standard barrier type matches up to each other to help that selection process. So in this table, we've included our flexible high-tension cable barrier system, our semi-rigid W-beam and modified thrive beam, and our rigid barrier system. So it provides deflection requirements and these kind of orders of bias that allow the designer to relatively know how these systems match up in terms of cost, impact severity, maintenance costs, also what the test levels are for them, and what vehicles those types of systems are designed to handle.
Yeah, so real quickly, Derwood, if you don't mind going back one slide, I'm just going to say something. I think I heard Dennis earlier, or somebody made a comment that why is high-tension cable barrier replacing W-beam guardrail, and it's not replacing it. It's another option that's available, and so this is intended, you know, to kind of help you guys decide which barrier you would want to use, where a rigid barrier are concrete barriers on the side of the road, modified thrive beams, a more robust version of guardrail, W-beam guardrails are standard guardrail, and high-tension cable barrier, which Derwood was really involved in. Do you want to mention a few words about high-tension?
Yeah, you know, just to bring up some of the high-tension cable barrier, it is still a developmental standard as far as the department is concerned. There was a moratorium on the use of high-tension cable barrier for a while, and that moratorium had to deal with some of the construction issues related to design of the foundation. So essentially, we were being too conservative with our foundation design requirements, and the foundations were becoming so large that it didn't, cost-wise, it wasn't cost-effective to use high-tension cable barriers. So we instituted the moratorium, took a step back, reevaluated our design criteria, got that fixed, and have put it back out there. Once we have a couple more successful projects with the new information, then we'll pull it off of developmental. But what we did do in this redevelopment of the PPM Chapter 4 was include high-tension cable barrier in the criteria, even though it is developmental, because we have confidence in the performance of the systems, and we want to see them to be used more often, specifically in locations where we're placing a barrier to prevent cross-median collisions. So we actually now in the PPM have high-tension cable barrier listed as the preferred barrier option for median application. So you're not where you're trying to protect, say, a fixed object or pier or bridge abutment, but where you're solely placing a barrier to prevent cross-median collisions. Our preferred option is to use high-tension cable barrier.
Yeah, so you can see you need plenty of deflection space behind it. So when it's out in a median by itself, that's a good use of it. Whereas other more rigid barriers deflect a lot less, but they also have more of a severe impact when a vehicle hits it. So that's the trade-off.
Right.
Okay.
So moving on through some of the PPM changes, you know, one of the questions we got asked about a lot here at Central Office was when to provide pier protection. So as you can see on this figure on the right, which was actually developed by our structures office some years ago, but it never actually made it into any of our publication manuals. We decided to add it into the PPM this time, and so essentially it's just providing a flow chart that complements the information that's in the structure design guide that helps the designer determine whether or not pier protection is required, which is, you know, the taller, more robust concrete barriers that we use when a bridge structure's columns or piers aren't designed to meet the current LRFD impact loading. But if it is located within if that pier is located in an area that would require protection as in terms of roadside safety, then the chart will lead you in that direction to using maybe a guardrail or other barrier option. But then as you move through, if you've met the pier protection criteria, then that would maybe send you to our current index 411, which is our pier protection barriers, which again are those taller, more robust barrier options. So if you're outside of the clear zone or outside of the requirements to consider it a critical bridge for design loads, then you may end up with either an index 400 guardrail or maybe an index 410 concrete barrier, depending on your situation. But again, just trying to provide a little bit better design guidance to designers who are trying to figure out whether or not pier protection may be needed on their project. Getting into some more of the specifics on where to place a barrier, we've added in some new information and new sections to PPM to supplement our criteria. So we list out what the controlling factors need to be when a designer is trying to determine where he's going to place his barrier, but then also providing the specific design criteria for either the setback or the offset of a barrier. One thing to note moving forward in DOT policy is the difference between setback and offset, because the terms were kind of intermixed in the past. When we talk about a setback, we're talking about the distance behind a barrier. So maybe it's the deflection space to the hazard or another element behind the barrier, or maybe it's a zone of intrusion for a concrete barrier. And then when we talk about offset, we're talking about the offset of that barrier from the traffic lanes. So now we try to make sure that it's consistent between what the term offset is and what the term setback is, and we'll kind of show you that in a couple of figures here. One thing I just want to highlight, that when it comes to the offset relative to face of curb, so when we're in urban areas, our now preferred option is to locate the guardrail 5 inches from the face of the curb, instead of the old preference was that it to be aligned with the face of the curb. And that's just basically to provide a little additional set or offset so that we can avoid maybe some nuisance impacts. A vehicle can get up against the curb without actually contacting the barrier. This was kind of instigated by some of the northern states that have to deal with snow removal, but in Florida we do have street sweepers and other maintenance equipment that we like to get up next to the curb, and it's nice to not have to worry about contacting the guardrail in all those cases.
The crash test is 5 inches.
Right, and a lot of the additional crash testing that's been done has been done at the 5-inch offset also. So, one of the changes that we did make, let me go back 1 second, just to talk about that curb placement. Previously in the PPM, we had this old figure 4.3.1, which was this kind of graph that you kind of went along the bottom trying to figure out maybe what a allowable offset from the curb face was at a given speed, and this table was kind of always getting misconstrued and misapplied. So what we did was get rid of that old graph, and we're going specifically to this figure, which used to be located in Chapter 2 of the PPM, but it has all the various criteria for offsetting guardrail, whether it be on a flush shoulder condition or a curb and gutter situation. So at the top here for flush shoulder, which hasn't changed, is our criteria for lateral offset of the guardrail, which is your shoulder width plus 2 feet with a 12-foot max. One of the things that we did update the language on was the offset for median applications, and the intent for median sides for guardrail offset was that we have an 8-foot minimum, so we didn't want guardrail to be any closer to the traffic lane on the median side than 8 feet. But then you would still apply the shoulder width plus 2 feet for all other conditions if you had a shoulder width wider than that. So that was previously getting misconstrued because it previously said 8-foot minimum for median shoulder widths less than or equal to 8 feet. So people were taking that to mean that it was an 8-foot minimum even if I had an 8-foot shoulder, but that wasn't really the intent. If you had an 8-foot shoulder, then you'd apply the 2-foot rule and you'd place that guardrail at 10 feet. So just trying to clarify the intent on that criteria and rewrote that portion of it slightly. The offset to shoulder gutters haven't changed from the previous criteria. For the curb and gutter installations, like I mentioned, for all design speeds with a curb, the preferred installation is the 5 inches from the face, which is how it's worded in the criteria. It can still be located at the face if we have really restricted criteria, which is why we mentioned the 0 inches here still. Just the preferred application will be the 5-inch offset. For areas where in lower design speeds, so less than or equal to 45 mile an hour, where we start to allow some acceptable further offset, the new criteria on that is that whether we're talking a type F or a type E curb, it's the same for both. That allowable offset is now between 4 and 12 feet. That's to allow those areas where maybe we have a sidewalk right at the back of curb, or maybe even we have a utility strip, but we still want to keep that guardrail as far from traffic as possible to avoid nuisance hits. So in those lower design speeds, like I say, less than or equal to 45 mile an hour, there is the option to move it a little bit further in that 4 to 12 foot range.
Can I explain the reason for the 4 feet, the vehicle instability?
And essentially that range, so you kind of have this area between 5 inches and 4 feet where you can't place the guardrail, and that's because vehicles can encounter some instability, and I don't really want to call it instability, but it changes the trajectory of the vehicle when it comes in contact with a curb, and it doesn't allow a vehicle to contact the guardrail in a manner where it will perform the way it's intended. So at this 4 to 12 range, that's the distance where a vehicle's kind of trajectory or motion comes back to basically normal with a flush shoulder type configuration, and the guardrail will perform as it's intended. So that's the reason why that range is kind of defined between 4 and 12 feet, because we want that vehicle's trajectory and motion to be as normal as possible. As I talked about with barrier setbacks, this table was previously included in the PPM. We've expanded it to include all of the barrier options, from the high tension cable barrier flexible to the rigid barrier. Like I said previously, this table was called offset, but to make that consistent when we're talking about these distances behind the barrier, we're referring to them as a setback distance. Yeah, and there's a picture over here on the left that kind of explains what we're talking about as far as that setback distance. For the flexible and the semi-rigid barriers, these setback distances are based on the deflection space that's available for those barrier types. For W-beam, we have these options for reducing the post spacing or nesting the panels, which is basically just taking 2 panels and matching them up on top of one another to increase the section properties of the section. And that by doing that, you can reduce the deflection, and by virtue of reducing the deflection, you lower the setback requirement for that particular barrier. Now, just to kind of allow people to understand the differences between the more flexible barriers and the rigid barriers, the reason why there's a setback distance required for rigid barriers is, although they don't deflect, you have a condition known as the zone of intrusion, which, for flexible systems, the systems absorb a lot more of the energy from the vehicles as they impact it. So through deflection, you absorb that energy, where when you come to a more rigid barrier, the vehicle has to absorb more of that energy and dissipate that energy. And a lot of times that occurs through vehicle roll. And when the vehicle rolls, it will tend to overlap the top of the barrier, or the compartment of the vehicle will override the top of the barrier. And so that's why we have the setback distances for rigid barriers, is to make sure that that area above the barrier and behind it is free of any objects that could come in contact with the vehicle compartment. Moving along with the barrier placement, we've also added new grading requirement section. So this is to cover essentially the criteria elements that are involved with the grading. Obviously, the standard index does an excellent job of kind of visually showing and detailing what the grading requirements are around Guardrail, but we want to make sure that people are clear on what the specific criteria are, and that's basically that you want any slopes approaching the barriers to be 1 to 10 or flatter. For Guardrail in particular, we want any of the slope breakpoints behind the guardrail to be at least 2 feet. That's for all barrier types, but it's particularly important for Guardrail, where you need to try to maintain that lateral stability of that post. So if you get it too close to the slope, then you start weakening the ability of that post to handle those lateral loads. One thing I want to add is that we've included this criteria for allowable algebraic differences in advance of a barrier. Essentially, anytime you have a transition in slope from the roadway traffic lanes to a shoulder, we want to make sure that that algebraic difference doesn't exceed 7%. That is our RRR requirement for allowable algebraic differences anyways, but we want to make sure that we highlight it in this chapter so people understand the importance that it plays in barrier performance. So if you start exceeding that algebraic difference, then just like with curbs, you start affecting the behavior of the vehicle as it departs the roadway, and its trajectory changes enough that that barrier will no longer perform as it's intended. We've also, as we reorganize the chapter, relocated a lot of the barrier warrant information to later sections, and again, that's to kind of help the chapter flow a little bit better. So none of this information really changed from the previous chapter 4, but when you're trying to evaluate how do I justify placing a barrier, then we have these elements included within the chapter that are those conditions that we consider to be more hazardous than a roadside barrier, because you always got to think about when you're evaluating putting a barrier in place is that although there are crash-worthy standards for these type of barrier options, they do constitute a hazard in and of themselves. So when you're trying to determine whether I'm going to place a barrier, you got to make sure that barrier doesn't constitute a greater hazard than what you may be trying to protect. And that's where the shielding requirements come into play in section 4.4.7.2, where we're talking about, can you eliminate the hazard, can you remove it, relocate it, make it traversable or crash-worthy? But if I'm getting down into the level where I'm trying to determine whether or not I need to shield that hazard, and it doesn't meet the threshold in a chapter in this previous table that I showed you, and I'm trying to determine whether or not the shielding of that hazard outweighs the benefits in terms of crash reduction or crash severity, then there's several tools available, which is the RSAT program or HSM analysis. And those are tools that have been available for some time and have been included within our criteria. I just like to highlight that anytime I get the opportunity. one of the things that I also wanted to point out was warrants for median barriers. And again, when we talk about median barriers, we're talking about barriers that are specifically located to reduce the potential for cross-median collisions. So the requirements for the placement of them are a little bit different. You know, you may have a barrier located within your median that's there to protect it because of some specific hazard, as we've highlighted previously, and you would locate those barriers in accordance with the requirements that I've showed you previously for those warrants. But when we're talking about cross-median collisions, there are specific criteria for the placement of those median barriers. Not a lot of that has changed. Like I mentioned before, high-tension cable barrier is now our preferred alternative for median barrier applications, and those placements are based on the criteria that we previously had about evaluating crash history, specifically within 1 mile of any interchange exit ramp. But we also had to add a section that we've highlighted here in yellow at the bottom for high-speed, high-volume facilities that are non-limited access. So we're talking about maybe some rural, high-speed, high-volume locations, and this was precipitated by a mandate from FHWA that we have some written policy on when designers need to evaluate the location of median barriers on these types of high-speed, high-volume, non-limited access facilities. Essentially, that policy is to evaluate the same 5-year cross-median crash history that you would on an interstate or an expressway project, but we also highlight the fact that you need to evaluate the different facility elements such as the alignment, sight distance, design speed, the frequency of median openings. There's a lot more elements that could happen on a non-limited access facility that might make you reevaluate whether you would put a median barrier there or not. So we have a policy, it's just not very prescriptive. So we want to make sure people understand that you have to start evaluating it, even on non-limited access facilities, but you got to take into consideration all the elements that might occur within that non-limited access type of corridor. And with that, that kind of ends the first part of our presentation today, covering the PPM. I'll open up here the chat box to see if there was any questions that came through. I realized that a lot of that was somewhat high level. We wanted to make sure that we covered the different aspects specifically relating to Guardrail that are covered in our design criteria. There's a more comprehensive evaluation of all the changes that occurred to Chapter 4, which is already posted on FDOT's website for our update training for the PPM. So if you want a more thorough explanation of that redevelopment, then by all means visit our training website and take a look at that webinar for the update training for Chapter 4.
It looks like you have 2 questions in the chat, Richard. Are you able to see them?
Yeah, that was Durwood speaking just then.
Oh, I'm sorry.
Let me look.
Yeah, in our chat box, nothing's showing up.
There is another box for questions. The chat, I think, is for us to talk, but the chat is what the audience is telling us. One question is, where can we find specifics about breakaway criteria or breakaway approved objects?
Okay, well, that was one of the areas that we improved on in the new PPM. So there is I didn't really cover it here. Like I say, I was trying to stick to predominantly Guardrail related issues, but we did. There is a new section of the PPM that is titled breakaway hardware, and that was to kind of provide that link so people could better understand what defines breakaway. And essentially, that's one of those areas where we do kind of defer to the roadside design guide because they've established the definition and what is considered breakaway. And we kind of highlight some of the design standards that are specifically designed to be breakaway. We don't cover every object that's out there that's considered breakaway, but just those that are considered standard, and we do provide that link now in the PPM between the roadside design guide defining what is considered a breakaway device.
And the second question says, I'm interested in the cost difference between standard third rail and concrete barrier wall. Could you please send any information you have regarding their cost for initial installation and repair statistics?
Since I can't see who exactly sent that, I would just ask that you follow up with either me or Richard with an email, and we can provide you any of that information.
Yeah, we track the pay and cost history per linear foot, so we should be able to tell you the latest difference.
And all of our historical cost information for all of our different pay items, regardless of whether they're barriers or any pay item, that historical cost information is on the FDOT website that non-department employees can locate, and it's tracked both on a running statewide 6-month average, but then it's also averaged out for every budget cycle. So you can go back for multiple years and look up what average costs of various pay items are on our website.
And those are the only questions we have in the chat at the moment.
Okay.
Okay.
All right. That's good. We'll move on to the next. Now I'm calling them parts because they got smaller. All right, so I want to thank Derwood. As I said, he did a great job with the PPM preparation. He's actually stepping out of the room now to go handle some other business, but if we need him for questions, I'll get him back in here. So moving on to the next part, as I said, and this next segment has a lot more pictures and visuals to look at, so it helps a little bit with the explanation of what's going on. And in order to just explain the general concept of Guardrail, like I said, I basically am planning just to show you each individual sheet in our FDOT standard, and then explain a little bit of history behind it, kind of how it works, and we'll try to keep it a little more high level and not get too much into design details. Although we're gonna throw some of them at you on each sheet just so you have a feel for it. And again, if you notice, Derwood kept talking about everything that had changed since the previous PPM, and now I'm talking a little bit about what's changed since the previous Index 400, but I will focus on assuming that designers to this are new as well, and just speaking about guardrail concepts in general, not necessarily so much what has changed, but we did recently change we completely redrew the entire index, as I said. And so just quickly to explain to you why we did that, I'm going to run through some points here real quickly. So what were the reasons for the change? Well, we wanted to improve the clarity. We wanted to provide updates. So as we said, we're moving from NCHRP 350 to MASH testing, which is the latest national standard. There's a big push for that. And so we want to make sure we're updated to the latest. And then effectiveness. And so the old index was 34 sheets long. Trying to make it user-friendly, it's now 22 sheets long, and now it has a table of contents. Before, it didn't really have an intuitive order. It wasn't real easy to find things in there. And we're trying to make it more simple now so even beginners can pick it up and understand it a little more quickly. The old index had really lengthy verbiage and passive voice. The new index has concise verbiage and active voice. That's something the department's heading towards, is just using more plain language and more direct instructions. Kind of shortens up the language a lot. And we also have note headings, which I'll show you in a moment. So the old index, the general note sheet, was an 11 by 17 sheet of solid text. Now we've moved towards essentially making it a lot shorter. It's only about a third text now, and it has note headings for everything, so you can quickly hone in on exactly the topic you're looking for because it has headings per note. The old index had old scanned-in drawings from decades ago. digitized drawings. They weren't very clear. The new ones are all drawn completely to scale, the latest labeling practice, so everything looks nice and clear now. The old index includes information for the designer. Something new we're headed towards in the department is now the designer information should be all included in the PPM, the Plans Preparation Manual that Dura was describing, or the IDS, the Instructions for Design Standards. And as I said before, Instructions for Design Standards have to do with information that specifically relates to one standard, and I'll show you where to find that in a moment. The old index had a lot of specification style language. The new index has the spec language moved to our specification, so that's information like length tolerances, height tolerances, material ASTM requirements, things like that are all in the specs now. They don't need to be on the drawings. As I said, the old index had the previous NCHRP 350, and this is the transition to the bridge railing. So transition to concrete barriers. I'll show you that in some detail, but we've now upgraded to MASH as far as that's concerned. So whenever you're transitioning to concrete railing for a bridge or just concrete barrier for the roadside, you got to stiffen it up and transition gradually. So it requires a complete design that we've standardized, and now those are MASH tested. The old index had only TL3 guardrail options, so it was essentially assuming all high speed. The new index has both TL3 and TL2 guardrail options. The TL2 is a little lower for lower speed, 45 miles per hour and less, and you can get some cost savings by using TL2 options if you only need low speed options. The old index had the length of need that used a simplified method based on the previous criteria, and the length of need now is based on our AASHTO roadside design guide criteria. So where is it? So the easiest thing to do, you just Google search FDOT standards. This site would come up right here as the very first result, and then you would go in here and it would, Design Standard ebook is the current publication. This gives you a nice long list of all of our standards, everything that you currently need to follow and currently being implemented. The DSR is something called the Design Standard Revision, and these all have kind of different caveats on when to use them. But so far on this DSR website, the only thing on there is Guardrail, and this is our new Guardrail standard that we're going to talk about, and I'll talk to you about how it's implemented in a moment. So if you click on the DSR, you then get this website, and our standards are right here. And now all of our design standard websites are set up the same way, where whether you click on the ebook, you click on the DSR, you have the index number. These are the index sheets themselves, or PDFs, and obviously the topic and the title. The IDS for designers that goes along with the standard is right on the same line, so you'd find that right here, and we'll actually talk about that in our next part. Design tool, this is where you'd find the length of need Excel sheet, so it's XLS because it's Excel format. And so that, again, goes with this standard, so you'd find it all on the same website. And then we also have DGNs, which is like the CAD file for these drawings. So if you needed to make a project-specific change for that, you didn't have to sign and seal it if you made changes to our standards, but you can open the DGN and just make your changes, and at least you have something to start with. The Associated Design Bulletin that gave the criteria for release is located right here. So it's all in the same area. We call that the one-stop shopping. So our implementation schedule, I'm going to attempt to move through a lot of these topics pretty quickly. And if you need more information on specifics, you can look into it yourself or send us an email. But essentially, everything we're going to talk about moving forward is considered a DSR to the 2016-17 ebook. The documents are available for use at the option of all the districts concerning FDOT projects for everything let prior to July 1st, 2017. It's optional. The previous standard is still available, and it can be used for projects let up until this date, but we wanted to provide the new option as kind of a way to sunset the old one and let people get used to the idea of the new standard and become familiar with it. We didn't want to rush the implementation on anybody and catch people off guard, because there are a significant amount of changes, so we're kind of slowly introducing it. And so that's why you have this deadline of July 1st, 2017. And then on July 1st, 2017, it will become mandatory. because what you're about to see will be introduced in the 2017-18 Design Standards ebook. It'll no longer be a DSR. And so on July 1st, 2017, it'll be the official standard. So now we'll start to look into some of the sheets here. So the way this is set up is that I broke up basically the sections we're going to talk about. The sheet number is in the upper right-hand corner. Each sheet we're going to talk about starts with a full clipping of the actual sheet, so you guys get a feel for the bigger picture of what it looks like. And then on following slides, we may zoom in on some of the details on that sheet, but at all times you'll be able to know what sheet we're talking about because it'll be in the upper right-hand corner here. And so I'll just walk you guys through it. I'm going to attempt, I may skip over details here and there because I'm just trying to give you a broad overview, and if you see a lot of pictures of how things look, and it'll let you know kind of what there is out there to be curious about. That way, if you do have to get involved, you'll know where to find the information and investigate it further. So for our first sheet, we have our table of contents. We've kind of started them off easy and explain where everything's located, and then obviously the general notes. So we added a table of contents over here. And just to give you a feel for the organization, we kind of grouped all the components together, and the titles of them have the first few words here are similar, so that way you can see, okay, well, sheets 7 through 10, 7 through 11, those are end treatments, 13 through 16, approach transitions, modify. It was essentially the Guardrail had been around for 3 or 4 decades, and any place information would fit on some white paper space, they'd try to fit it in there, and it became very, very disorganized and hard to find things. So we've reorganized from start to finish. And so sheets 2 and 3 start you off with the basic Guardrail run types, the repetitive Guardrail. If you've never seen Guardrail before, this is where you'd want to start so you understand, okay, just the typical repeating post spacing height, that type of thing. That starts you off. Then 4 and 5, you get your basic components that define those Guardrail run types. Sheet 6, we consolidated all of our Guardrail cross sections onto one sheet to explain all the different grading requirements and the heights and how everything looks depending on various situations. Sheet 7 through 12, we have the end treatments that are broken down into approach terminal, trailing anchorage, and CRT. So this is a point of emphasis here in that we have a nomenclature change where we're now following AASHTO. Our approach terminals, AASHTO would call it a terminal, used to be called an end anchorage assembly per DOT. The problem with that is an anchorage per AASHTO is something on the trailing end. So we're moving to the national standards. We're changing some of our naming conventions. If you look at the APL and you're looking for end anchorage assemblies, it'll still say end anchorage assembly, and then in parentheses it says approach terminal. After about a year or so, we'll drop the end anchorage assembly. It'll just say approach terminal, and that will be the official new term. And essentially, we're following AASHTO. AASHTO defines end treatments as the blanket. So if you're ever confused about, well, what do I call that thing that goes on the end of Guardrail? I'm not really sure. If you say end treatment, that pretty much covers them all. Then the subgroupings are approach terminal for the approach end. We wanted to make this obvious. Trailing end, trailing anchorage. This goes on a trailing end where you don't expect a head-on collision. And then a CRT for layout. So we'll get into that. I'll show you pictures of it coming up. 13 through 16, we got transition connections to rigid barrier. We'll show you some good details on that. 17 through 18, we then show how examples of how all these different segments fit together in various scenarios so the contractor gets a feel for how they fit together. And we show some good examples of that. Then we have Guardrail supplements like rub rail and pipe rail. I'll explain those in a minute. Modified post mounts. That would be for mounting into concrete structure you couldn't avoid, or if you had to put in a shallow mount to avoid utilities, you have a different kind of post, or if you had to mount through concrete surface, you'd want to use a special frangible leave out where you block out the concrete around the post, and I'll explain that in a moment. Then we got miscellaneous details. All right, these notes, I won't go through all of them. I tried to shorten this up a little bit. So essentially the main thing is this is considered 31-inch height guardrails. That's what note number 2 explains. All the compatible hardware that goes along with it's considered 31. In past years, it was considered 27-inch guardrail. and this is all per Midwest Guardrail design. We measure our guardrail to the center of the panel, so it's not always clear that that's 31-inch guardrail, and we just wanted to make it obvious so that people realize that, okay, FDOT is using the latest and greatest. Note number 8 we'll skip to is basically explains to contractors how to connect to existing guardrail. This will be a little bit easier to explain when I have some pictures to show you. But essentially, existing guardrail can be lower height, 27-inch, and the splices where the panels connect together used to be at the post, and now they're at midspan. And so when you connect to existing guardrail, you need to do it over a certain distance, and we just explained to the contractor how to handle that to make it a little more clear and easy for them. Number 9 explains that the plan's callouts will correspond to this standard. So, for example, begin-end guardrail or begin-end taper, things like that, we have that in our standard that will correspond directly to the plans. So the contractor could figure out exactly what the designer is trying to tell them, and that's what note number 9 explains. And then note number 10 mentions briefly, the contractor on how to measure length, where essentially you're going from post 1 to post 1, end to end. You're including all the end treatments. That's how you get your linear feet of guardrail. It overlaps with end treatments. It overlaps with approach transitions to rigid barrier, because those prices are considered over and above what guardrail price would be. So there's a little bit of an overlap there, but it keeps it simple because when you call out your begin-end guardrail, you know exactly where it's located, so you can see that there's no conflicts and the guardrail is going to fit. All right, so getting into sheet number 2. This is kind of where we define, I guess, the bread and butter, the good old repetitive TL3 guardrail. And I say repetitive because, you can have a half a mile of this, and this is defining essentially the basics of guardrail. And it gives you the height. I'll show you that on another slide. But basically, this one applies to TL3. Remember before I said we now have an option for TL3 and TL2 guardrail. So I'll show you TL2 in a moment. This is TL3. This is the same as our previous standard. It's just detailed a lot more clearly. Here's just a photo of what it would look like at 6'3" spacing. Essentially, you have a truck impacting it. It looks like this is some testing being done at Midwest Guardrail facility, safety facility. And I guess one point to make from the picture is that per MASH testing, the maximum impact angle is 25 degrees. Sometimes there's a misconception where, hey, if I put guardrail out there in front of a lake, it's better than nothing, and might as well just throw it out there. And I've seen designs where they're expecting an impact to be at 90 degrees coming from the roadway. That is their approach direction, and guardrail simply will not function correctly that way. Either it won't capture the vehicle, it'll just slice right through and go into your hazard, unfortunately, or it will be too rigid of an impact at a 90-degree angle, and there won't be enough energy absorption, and the results for the drivers can be really catastrophic because guardrail is designed to be impacted at a 25-degree angle, and it kind of has a smooth redirect, and it sends the vehicle kind of back in the direction of the roadway. And that's the way it's designed to use. So designers need to understand that it's not going to help you from a 90-degree angle unless it's a specific design. And so I just wanted to emphasize that. So some of the points about our typical TL3 guardrail is that it's 31-inch height. It has 6'3" post spacing. That's the standard. It's been that way for a lot of years. It now has a midspan panel splice, so you can see it's located at midspan. Previous guardrail, a lot of existing applications, it's 27-inch height, and this splice right here is located on the post. So when you go to our new guardrail, you need to quickly transition to the new type of height and spacing. The height allows for increased energy absorption. And I think Dura was trying to explain that when you have a midspan splice like this, you then get tension running along the length. When it gets impacted, you get tension running along the length of this ribbon here, and that makes it a lot stronger. When it's located at the post, this could end up just being a one moment, I gotta turn off my phone real quick. Okay, excuse me. When you get a splice right here at the post, it could end up just tearing in shear, and that's not good. So in order for this to work the most efficiently, it's at midspan, and then you're always getting a tension type of failure, and it's a lot stronger in tension than it is in shear, like this. We have our 2-inch miscellaneous asphalt pavement. That's the most strip that's always required at the base, and then we have 1 offset block for posts. Quickly, I won't go through all these notes, but the main emphasis here is that designers really can design to the nearest 6-foot 3-inch panel length. Going back here, we have our basic 12-foot 6-inch panels, but we allow the contractor to end the run with a 6-foot 3-inch panel and a 6-foot 3-inch post spacing as usual. And that means that designers can design to the nearest 6'3". It used to be 12'6". So that's something that's new with our new standard. Something quick to point out is, mid-span panel splices. Basically, this exposed ridge here needs to go on the downstream end. And traffic will hit this. There's a redirect here. It'll kind of rub along the railing. You don't want it to get snagged on that ridge, and so it performs best when it's downstream. Now, another thing we get questions about is, we've actually had contractors out in the field that for one direction of their traffic phasing, they had panels one way, and then they were going to pull all the panels off and replace them so that this ridge would switch directions, and you don't need to do it for traffic control phasing. The guardrail is still rigid, and you still get a nice smooth redirect. It's just ideally you want it downstream, but for traffic control phasing, you don't have to worry about it. You essentially build it for the final condition, and that's it. And then another point we're making to contractors is that guardrail is the base configuration, and so all these other things that we're going to talk about, like pipe rail, double face guardrail, rub rail, D-posts, they all get added on to this general configuration of height and midspan panel splices and post spacing and things like that. So there's other additives to this, but the general guardrail configuration still applies. It just gets added to. Okay, so moving on, we have our TL2 option. This is completely new, permitted for 45 mile per hour and less design speed. So if you know you're not going to have it as a high design speed, you can consider using this stuff. And essentially, you got 12'6" now between posts. So you got double the post spacing. You're going to have half the posts, and you can get some cost savings out of that. Here's just a picture of how it looks. You can see clearly the posts are a lot further away from each other. Still redirecting a fairly large truck. But you can see that if you have a lower design speed, it still does a good job. It provides a smooth redirect. That's the vehicle at rest. So the vehicle impacted, slid along, and ended up over here. So even though you have a lot less posts in there, it still works properly if you keep your design speed down. So it's the same as general guardrail, except it's got 12'6" post spacing. And then getting into a little more detail, the runs will end with a 9'4" 4.5" panel. That's the one caveat to using this, because that makes it compatible with all of our other segments. Every segment I'm going to show you ends with a 6'3" post space and a midspan panel lap splice. And so it looks like this. Now, obviously, TL2 is a lot different. So in order to connect to all those other segments, they have to put in this 3/4 spacing right here, and that's how that looks. Sheet number 4, we basically are showing you our panel options. These things are used for all of our different types of guardrail, general, low speed, approach transition, end treatments. Essentially, the traditional panel jargon, these are the increments you're working with when you're talking about guardrail. So our old full panel used to be 12'6". Now we're allowing 25-foot panels as something new, and that's considered a double panel. Half panel, 6'3", which can be used. Quarter is 3'1.5". Now, one thing to understand about quarter panel spacing, people will say that a lot because that's where the slots are generally placed. And if you understand where these slots are for post bolts to connect to the post. And these, by default, are prefabricated to 3'1.5". So once you understand that, you can define a lot of different panel lengths just by explaining the number of spaces between those, and then just simply knowing that the end ends with all of these splice bolt holes. So each panel has the ends like this, and then number of end spaces, and you can define a lot of different panels just understanding that. So basically, the 6'3" panel is now a shorter panel available. We're saying that's allowed for use. And what's important about this is another major concept is we have a new guardrail link tolerance of plus or minus 3'1.5 inches. For really long runs of guardrail, where exactly that guardrail ends is not very critical as long as you're meeting your length of need. So we didn't want contractors cutting guardrail panels and trying to be very, very critical of having the guardrail end on the exact inch That's not very important. If it's a nice long running guardrail along a freeway, it can go to the nearest plus or minus 3 foot 1.5 inch. What that allows is they can add or subtract a 6 foot 3 inch panel from the end of the run, and they'll always meet that tolerance. And so we just don't want a lot of time wasted out there when it's not really necessary. Now, the other thing is we have a real big caveat on that explains, well, the engineer, the inspecting engineer out there can decide to tighten up that tolerance. If you have like an urban setting and you're trying to terminate guardrail before a side street or a sidewalk and you really need to fit it in there, the run of guardrail should be a lot shorter so that the designer can design it correctly to the nearest 6 foot 3, and there shouldn't be that much of a variance like for vertical curvature and things like that. So the point is that the engineer, for like an urban setting where you're really trying to fit the guardrail, and they could overrun that tolerance and make it tighter where practical. So it's just common sense. If you really need to fit guardrail in somewhere, you're going to need to be a little more careful about making that thing fit, and the designer can generally make it fit properly. And a shorter run of guardrail is not going to have that much of an effect that can't be accounted for, in the design plans. So we also have 9 foot 4.5 inch panels, 50 foot 7.5 inch, and this is basically a 3/4 panel and a 1 1/4 panel, and this is used for transitioning to the mid-span panel splices of existing guardrail. So remember we were saying before that existing guardrail has the splices located on the post, but for any new guardrail that attaches to that, we're going to require our panel splices to be mid-span. So if you use one of these panels, immediately, the very first panel, it automatically transitions you to a mid-span panel splice, and it's taken care of. Now 25-foot panels are now available. Previously, maintenance crews, I think, thought that you always have to replace the exact panel in kind. That's not necessarily true. So they can replace a 25-foot panel with 2 12-foot 6-inch panels, and the 12-foot 6-inch panels fit on their trucks. So essentially, we don't have to have maintenance governing our maximum length of panels. And when contractors use 25-foot panels in construction, they could fit those on their trucks just fine. They end up using half as many splices, and that results in a lot of man-hour savings. So contractors are really happy about going to 25-foot panels. It's just a lot less work to assemble and splice all these things together. All right, moving on to sheet number 5. Just give it a brief overview. We're covering all the options on one sheet of the posts and the offset blocks and how they all fit together. Previously, this was scattered around in a lot of sheets, so now it's all together. It keeps things simple. A visual of kind of what our post and offset block configuration looks like. This would be a typical 6-inch steel post, a typical 7.5-inch timber offset block, and then you got your W-beam running along here. One real quick thing to mention is that we got our timber post and steel post are both for use at the option of the contractor, and they can pick whatever one they want, and then whichever one they choose, there's a standard post length now, which was 6 foot 6 like it always has been, and now we have this new thing called a deep post, and I'll explain to you in a moment why we'd want to use a deep post. It's essentially for when our slope breaks right at the center line of the post versus the normal 2 foot behind the post. So if we have less soil surrounding the post is going to have to go deeper, and so we have a new condition now to try to save space called the slope break condition, and you can use a deep post, but you need a lot of approvals to do that. So moving along to our guardrail sections, we've consolidated all these cross sections. There's a lot of good information on here about how things are graded, where things are measured from, and we'll focus in on some of these details in upcoming slides, but it gives you your guardrail heights and depths, your adjacent grading, explains where the 2-inch miscellaneous asphalt mow strip goes below the base you can see here, explains how to handle a concrete sidewalk. We've never before really addressed how to handle guardrail near concrete, and it's very important to handle that correctly. And so now we've addressed that. It explains the curb conditions, shoulder gutter, and when to use rub rail. As I was saying now, just zooming in real quick, we're going to kind of skip over the basics and focus on the new stuff. So this is for using deep posts, and essentially you can see here, normally a slope break would be 2 feet behind the post for a normal standard installation, and that is going to be what happens 98% of the time. You're going to have a standard installation. It's easier to maintain, and you can put an asphalt mow strip around the base of the post. But in this case, if you're really tight on space, like for instance, you have a triple R project, you can't plan properly for right-of-way, and you're trying to save every foot possible in your cross-section laterally, you might want to have this slope break right at the post to save you that little bit over 2 feet. And so in order to do that, you have to have these deep posts used because, like I said, you have less soil back here surrounding your post, so you got to go a little deeper. But in order to do that, you need the approval of the district design engineer. And these are a lot harder to maintain, and so we want designers to be thinking about how is the drainage going to be handled, how is the maintenance going to be handled. And we expect to see these used on a very limited basis, but it is a new option. And shown in the standard with the note that these may only be used when they're shown in the plan. So the designer governs whether they're used or not. The contractor can't use them whenever they want to. So we have a typical grading and pavement placement detail, and rather than define all the basics over and over on all these unique typical sections, we just do it once. And then on the unique typical sections, like for curved or shoulder gutters or things like that, you may have dimensions that supersede these, but you start with the base layout essentially. And so we're defining a 1 to 10 max approach slope. That's normal and consistent now everywhere. That used to vary in the previous standard, but these things are always crash tested with 1 or 10 or less max slope, and that's the slope we need for this to function correctly. And again, you got your 2 foot minimum to that slope break. So if you use a deep post, slope break would here. That's a very unique case. In general, it breaks 2 feet behind, and you have plenty of soil around here to resist the rotation of the post. One thing I wanted to point out is showing some more cross sections. Is you notice where the height is measured. Height is measured a little differently in each case. Here, when you're measuring essentially from the roadway surface elevation, when a vehicle hits this, the curb wouldn't have had any effect on the vehicle yet. That's why you have to place it at 0 or 5 inches from the curb, and so H is measured from here. Now, if you recall in the PPM, we were talking about, okay, well now if you're going to go behind the curb, you have to go at least 4 feet. You can't put it somewhere in the middle. You have to put it 4 feet or greater, because the vehicle will hit this, and it tends to vault, and it will have to stabilize just a little bit and become more of a normal motion before it hits guardrail for the guardrail to function properly. So you want to put this some offset behind this vaulting curb right here. Then the height is then measured from directly below the guardrail, because by that point the vehicle will have raised up. It won't be at the street elevation anymore, it'll be higher. So you'd raise this up a little bit. And then here again, you're measuring from the back of the shoulder gutter. So that's essentially still the street elevation. Joe had mentioned this, 0 or 5 inches. The designer will determine if it's 0 or 5. They put that in their plans, the contractor follows it, but in the standard we show both because it could be either one and it gets locked in. It's not a tolerance that's 0 to 5 that varies, it's 0 or 5. And so we may change our PPM to say this is well or 5 instead of 2, 5. And yeah, it's for avoiding hits of rearview mirrors and things like that. All of them are now crash tested. The latest crash tests are with the guardrail 5 inches behind the curb, so that's a significant change where we're expecting most of our new installations to have a 5-inch offset. Something else I just show real quickly is we call out a thing called lateral offset in the standard. This is really just a placeholder because this is defined in the plans. However this is drawn in the plans will determine where that face of guardrail is. So you have a typical section in the plan view. The designer determines where the guardrail goes. The contractor follows it. And so here we just got a placeholder in the standard, and we explain in the standard that that's defined by the plans. And so again, if you want to find out what your lateral offsets are, you look at the PPM section 2.3 for shoulders and figure 4.4.12 for offset to guardrail. That's the designer information is in the PPM. So we got more cross sections, skipping over most of the notes. We're explaining what to do in for flush conditions and shoulder gutter condition, and we have more of the same type of information, just showing you where the pavement falls, without getting into too much detail. And we say that rub rail, one thing I wanted to point out is that rub rail is really now only permitted for the median side of the slope, where you can't have a 1 to 10 approach. Since a median slope has a 1 to 6 maximum slope, you're essentially going to use rub rail when your slope's between 1 to 6 and 1 to 10. And so you put that on that side. That increases the capture rate when you have a less than ideal approach slope. So we just define that real quickly. All right, so one of the other concepts we have, and we should be able to get to this, is that when a post is mounted near concrete, you need to follow a certain set of conditions. So when you're near a concrete sidewalk, you can't just basically plant the post and then pour concrete around it. The post, when this vehicle impacts this, has to be able to rotate in the soil as it was crash tested, and it absorbs that energy. It allows for a redirect the way it was intended. If this is too rigid at the foundation, the post will not rotate, and in general, W-beam can just break. It won't capture a vehicle like a truck. It could just pierce right through, and so the guardrail won't function as you think it has to. So this was not even addressed in the previous standard, so we're handling it now, where we're saying if you have a concrete sidewalk, you need to be 7 inches away from that. And what goes around the base of a typical guardrail post is 2-inch miscellaneous asphalt, which is considered flexible. It also tears, so it allows that motion of rotation without the concrete interfering. Now, if you can't do that, and you really have a tight situation, constrained scenario where you have to put the post right through the sidewalk because you're trying to fit a lot into the same section, then you use this thing called the frangible leave-out, which is something new. It's been crash tested, FHWA approved. It has essentially what you're doing is blocking out this area right here and making a square around it, and then you backfill it with really low strength material. And so you're doing that for aesthetics and keep the vegetation from growing through and making it look nice. But the material was considered frangible. It will break away when this is impacted, and so we have some details on that coming up. And then one other thing we mentioned real quickly is because we're talking about concrete sidewalks, we'll go ahead and mention when to use pipe rail. This is for pedestrian safety. And so whenever steel posts are used, essentially you got this metal flange sticking out. Now if you have a bicyclist riding by, they can get snagged on it, and that's not very safe. Or even worse, the top of the flange comes to a point, and that might actually impale somebody. And so we're obviously wanting to avoid that for pedestrians. We want things to be as safe as they can possibly be. So when you're within 4 feet of a sidewalk or shared use path, the designer needs to know to place this in the plans, assuming that the contractor is going to use steel posts. We want it to be quantified. And so it essentially protects that sharp edge right there of the back post of that flange. And so that's the criteria for when a pipe rail is used. And we have a whole sheet dedicated to pipe rail coming up. Now these we're defining our approach terminals, how to handle what to do on the end of guardrail. And this is obviously, as the name implies, we try to make this now very intuitive, easy for people to learn. This used to just be called end anchorage assembly, and you really had to read through some paragraphs to find out what it was even used for. Now if you look at the name, you pretty much know the approach terminal. If that's on the approach side, if you have head-on traffic that are going to hit this thing head-on, you want to avoid the W-beam spearing through the vehicle, that's what these are designed for. They're designed to basically, in some cases, extrude the guardrail or redirect the guardrail away from the vehicle to not spear into it and to absorb a little bit of energy before you get to the more rigid portion to be safer for the vehicle. And so these are designed for head-on collisions as opposed to the trailing anchorage, which is only designed for the trailing side. The other thing these do is develop a little bit of the ribbon strength, so you start having the redirective capability at post 3. And so it's kind of tied down a little bit to start giving you some guardrail rigidity. Here are examples of what some of them look like. This is it's called the soft stop. These are on our APL. These are called the approved product list, and these are department-approved devices that contractors can pick from. And so we got one called the soft stop, one called the SKT, just to show you some examples of what they look like. Call it out some simple things in our drawings. We have our begin-end guardrail starts at post 1. So here's where you start measuring guardrail, post 1. And then this corresponds to the call out in the plans. If you remember, I had mentioned that every time a segment, this is considered a segment, attaches to another segment, It does so at a 6'3" post space and mid-span panel lap splice, and you can see general guardrail continues on this way. And so that's where you connect the general guardrail right here. Sort of quickly, I mentioned maximum flare. Flare is used to reduce length of need, and it's also nice to move this away from the traffic as far as possible to avoid any impacts at all. And then also, there's a thing called a shy distance, and drivers going along the roadway, to kind of a subconscious thing, if there's an object right on the side of the road that's beginning, they'll tend to shy away from it. And so under normal conditions, they might veer away a little from something right next to the roadway. So if you flare this away from the lane, it kind of reduces the propensity for vehicles and drivers to kind of shy away from this thing. And so they drive more in a straight line, and that's desirable. So in general, when you have room for this thing, you have 6 foot of clearance behind it for flat space, you want to flare this as much as you can to a maximum of 4 feet. So quickly, sheet number 8, it's the same idea. Sheet 7, now we're showing a little more advanced conditions where it's either curbed or double face segments. And so essentially the curbed, we'll just focus on one point of emphasis. When we're requiring type E curb now in front of it, these things are really only crash tested on level terrain. So if we're going to use it with curbing, we want our flattest curb possible to result in the least amount of vaulting and instability possible. So type E lays a lot more flat, but it also still allows for water conveyance. So you can continue your curb segment on, but you switch to type E for a curb segment, and that's a new requirement. The double face segment, real quickly, it's the same philosophy as the other approach terminals. I guess one point of emphasis is that in all of our previous standards, whenever we had double face guardrail, we just showed a symbol for crash cushion on the end, and crash cushions are the most expensive option available, and they're not always necessary. In our IDS, we give a more in-depth explanation on when to use a crash cushion, and the PPM as well. I'm not going to get into it too much, but the default option and the lowest cost option is to use a double face approach terminal. And so we wanted to put that in our standard to sort of raise awareness that this is an option and that it should be used probably most of the time. Unless you're in an area like an approach, like a gore area of a highway where you have a ramp and you have a lot of vehicle traffic aimed directly at the terminal, and there's a lot of decision making and weaving going on right in front of it, you expect that to get hit a lot, the end of that guardrail to get hit a lot. That's a case where you might want to consider crash cushion because they have lower cost of maintenance. You don't have to replace the entire system. If this gets hit, you generally replace the entire system. If crash cushion gets hit, they all brag over how much it costs for them to do repair work and reset it to the point where it's good again for another use. And so they're initially more expensive, but then their maintenance is lower cost. Here, you have initially lower cost, but then you got to replace the whole thing if it's hit. So you really want to use this when it's truly on the roadside and you don't have vehicles directed straight at it, and you expect it to be hit a lot less. But you could save a lot of money just by using this as a default option. Something that's new is regardless of whether you're on a median or not, you need 1 to 10 approaches on both sides because that's how it's crash tested. And to make that happen, you may not be able to have some steeper median slopes for drainage. You may have to have level terrain here and run your drainage right through it using pipes, or you might have to do a little bit of a design there. But the idea is you need to design roadways around how guardrail will function safely and not just fit guardrail in after the fact. It needs to be planned for. So our trailing anchorage, as the name implied, is to be used only on the downstream trailing side. So you see here direction of traffic. And maybe, let's see if I got direction of traffic up here. So direction of traffic is clearly going right to left for an approach. Now we're showing it still going right to left, but now we're talking about the other end of the guardrail, so that is the trailing end. This is not designed for head-on collisions. Essentially, the function of this is to tie the guardrail down, to develop that ribbon strength so that if a vehicle hits it, almost all the way to the very end, you have redirective capability. If you didn't tie it down, then all these things would just pull away and it really wouldn't redirect you or anything. The vehicle would pass right through it. And so you always have to have some type of end treatment. So don't expect it to be hit from head on. You put a trailing anchorage. And essentially it's when you're outside the clear zone of any opposing lane, when you're outside any clear zone of approaching traffic, you put a type 2. And so for a two-way road, you can have traffic on the opposite side of the road going the opposite direction, but you're within the clear zone of it still. And so in that case, you want to put an approach terminal on both sides. So we'll explain a little more of that coming up. All right. So again, we call out our begin end and guardrail station, and just so you see how it all works out, we're consistent with that throughout the standards. Here we have some construction components that are used on some of our end treatments. I'm just going to start flying through this now because our time's running a little bit short. But I really did just want you to have a feel for what's out there, and if you want to know more information, obviously you can take your time with it and read it yourself, and we try to make it as user-friendly as we can. But so this is called the controlled release terminal. It's for the CRT system, so this is an end treatment. It's only used in this case. It's right here. So when you're trying to terminate a radius, you use that end treatment. Now, when a CRT system is used, this is one of the only types of guardrail that's designed for about a 90-degree impact. You have the principal roadway going left to right, and you're essentially trying to continue this with guardrail that's on a side street. And so you can choose one of these radius options to basically turn the corner. And you have to draw this in the plans exactly how it, basically you have to make this corresponding to the design standard. And you have to use the entire system. We've seen cases where designers tried to use half the system because that's all they had room for, and that really wasn't the best option. They probably could have just used a flared end treatment, and it would have, that would have been a correct design. The entire design is the only thing that's crash tested that works together properly, and so you have to use it in your plans exactly how it's drawn here. And so that's just our most important point to make. One of the things, okay, so in the plans, they'd call out begin end, CRT, call out the radius. We got our begin end guardrail shown. That's where guardrail starts being measured. This is something very important too. So not only do you draw this exactly to scale in the plans so that you know it will fit properly and that you know all the posts will fit in there, but you also have to follow these minimum clear area limits in your design. These are all breakaway posts. The only reason that this guardrail functions with a 90-degree impact is that all of these posts break away to absorb energy, and then you have a really large deflection back here that takes up almost the whole clear area, and all that deflection is absorbing energy, keeping the vehicle from passing through, and it's capturing the vehicle. So it's very, very important to keep this whole area clear. If you have some type of fixed object or a canal, the vehicle is going to go right into it, and that's not safe at all. So we have to pay real close attention to the way it's drawn. This is a lot more clear than it was in the previous standard, so it will probably be followed a lot more closely. The previous standard was simply hard to really follow, and so that's why we saw all kinds of variations that simply aren't crash tested and won't work. Okay, so we get into our approach transition connections. These are new. If you guys recall, the old standard used to be called Detail J. These are now match tested. And so basically what you have here is a concrete barrier or a bridge railing, concrete bridge railing, and we're showing you how to transition to that. And this is a standard where these are crash tested, and you get reduced post spacing as you get closer and closer, so the rigidity will match what the wall is. If this was very soft and flexible, and then you had a rigid wall, if a vehicle it'd get pocketed, so that it basically go in a pocket and get snagged right here, and that's very bad to have instantaneous stop of a vehicle. So you want this to slowly gain rigidity. That way, if the vehicle hits right here, this is very rigid, and it's rigid right here as well, and so you won't have any snag, and you have a nice smooth redirect, and it's safer for the vehicle. And so that's why you need to use these standards every time you're connecting to a rigid barrier. This new design is shorter than the previous design, which is kind of nice. And we have a raised alignment curve, which is required to prevent wheel snagging. The section views are on sheet 15. We won't go into too much detail on that, but this is essentially how it looks. This is multiple angles of a crash testing facility, different crash tests. One thing I want to call out, okay, this is where you begin your guardrail measurement. So rather than a post 1, if you're at a rigid barrier, you connect at the center line of this splice, and so designers need to know that. The edge of the rigid barrier is slightly different by 7¼ inches from where the begin guardrail starts. So that's a little nuance that designers have always paid attention to these types of things before. And there's the end of your transition of your curb. So you have a curb along here that's called an alignment curb. And by the time you get to here, you'd be switched to a type F or something general, a shoulder gutter or something like that. This is the point here at section EE where you would transition to a typical section per the PPM. So we wanted to make note of that. All of this guardrail is required to be parallel to the bridge railing and right next to that shoulder line. But in general, in the PPM, your guardrail is at a shoulder line plus 2 feet. So you transition to it at a taper rate here of about 1:10, 1:15. Here's a TL2 version, same as the TL2 guardrail. You can use this for design speeds less than or equal to 45 miles per hour. And you can have some cost savings because it's a little bit less robust of a design. But if you know you don't have high design speed, you can save some money by using that. Here's the pictures of how it looks. These sections go along back here. I don't know if we have any plan views. So all these sections called out. Right here we have the same thing for the TL2 version. And then, so we're essentially defining what happens with all these sections and what the curb is doing at all these locations. So you can go from your alignment curb that's required to a shoulder gutter. You can go from the alignment curb that's required to a simple raised curb, or you can go to no curb at all. And so we're just showing you how to handle all that. So you know it's there. Here's the same thing, but if you happen to have double-faced guardrail, now you don't need an alignment curb, but you do require some offset blocks to transition you to the width of the rigid barrier. This guardrail system is a lot wider than the rigid barrier, so you need to have these trimmed offset blocks to get you where you're going, and you need about a 12-foot 6-inch overlap, which is a little different from the previous. So on sheet 17, we're now showing how all of these elements fit together. So if you notice on the previous sheets, I hadn't even pointed it out, but we have the LA length of approach transition defined, and we tell you exactly the length, and we have an LE length of end treatment defined. And so you can see how all these segments fit together. In between is your normal guardrail run, what we call general guardrail or low speed. And so here's where you taper to it. You got to begin, end taper. That would be in the plans. And that's the new way guardrail is designed now. We're expecting designers in the plans, and we have a lot more detail on how to do this, to call out begin of guardrail, end of guardrail, begin taper, end taper. This defines a lot of information for the contractor and allows a lot of flexibility for the designer. The designers are going to have a little more control. Previously, we had a lot of pre-designed guardrail tables on how things work, and it was very difficult to follow what was your scenario, and designers weren't sure if they were supposed to figure it out or if contractors were supposed to figure it out. And so we're making it more clear that the designers have control over this, and they tell you these 4 stations and offsets. And when you do that, you can define the whole thing. This is another concept called our median crossover. And in this case, you're protecting, this is when you have a very narrow median, and this rigid barrier is in this guy's clear zone. So coming from right to left, you're within the clear zone over here. And not only that, because you're in the clear zone, coming from left to right, the back of this guardrail is considered a hazard, and it's within the clear zone for these people. So you have to have panels on the back. Now, since we've established that we have panels on both sides, the way to get the shortest run of guardrail is to start tapering across the median. And what it comes down to is that we have a length of need program, or if you put in some variables, it'll tell you the station and offset here, 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 and here. And then designers put that in the plans, and it's designed properly. And we have, it's a pretty advanced little equation that calculates that, but then designers don't have to think about it. And so that's part of our design tool on that website. More layouts to rigid barrier. So one other thing to mention is that if you have only the shortest case possible, where you're just trying to protect a rigid barrier and do nothing else, you'd have LA plus LE and no offsets, no taper, no anything. You just put those 2 together and you're done. And so that we're just mentioning our shortest possible guardrail is to omit the general guardrail portion here. And again, we show you begin end guardrail on both sides and our begin end tapers. Those are what designers are expected to call out. and I got into this already. I kind of spoke on it. Just speaking about, this is typically a dual bridge situation where you have a narrow median. And like I said, for these people coming from right to left, you're protecting that barrier. Then, because you're so close, this back presents a hazard for these guys going left to right, so you put panels in the back. And our Guardrail Length and Need program will help you design this. That covers a lot of cases. And again, here are your basic designer call-outs. And if you do those things, and by the way, go Gators, then you can design your guardrail. This is on the trailing end here. And again, we just show some more layouts, how it all fits together. We show our trailing anchorage. That's our type 2, and so how all these things fit together. We mentioned that on sheet 18. We show rub rail details. Before, we showed when to use rub rail. So basically, on a median side, when you're between a 1 to 10 slope or 1 to 6, you go ahead and put rub rail on there. It helps redirect vehicles on a steep slope. And so now we have nice, clear details on that. On sheet 20, we have our pipe rail. Remember, we mentioned this for pedestrian safety, where you're guarding. Here's a nice ISO. You're guarding the steel flanges here from pedestrians getting clipped on them or getting stuck, or even possibly, getting cut by the sharp edge. So we're providing some protection for safety of pedestrians. And here we're offering some more detail on how it's built, how it's constructed. And then here are some of our modified post mounts, where we're talking about if the post at its 6 foot 3 inch spacing happens to fall on top of a structure, here's how you'd handle it. And you essentially use a base plate. You can mount to the structure directly. If the base plate would fall on the edge of a concrete structure, we don't allow that. So either you can shift it a quarter span that way and then get completely on the structure, or you shift it a quarter span that way, and now you can just plant right in the soil like typical guardrail. Designers can add extra offset blocks. We have all this criteria in our IDS of exactly how to do this, and we spend a lot more time on this in our other training. For something like underground utilities that are very shallow, we offer this option where you don't have to go nearly as deep with your post, and you only need to go 2 feet deep with a little bit of a concrete encasement. And so this could help you handle dodging utilities underground. And then we did mention our frangible leave out. I was saying that you block this out right here. When you're in a concrete situation, you don't want solid concrete poured around the base. You want a lot weaker material. So essentially, the contractor would leave that blocked out and backfill it with low-strength flowable fill. It's like 150 psi, and that will be considered frangible. So when a vehicle impacts this face, it will rotate properly in the soil the way it's supposed to. So these are all kind of your modified posts, and so we got them all on one sheet. So it's easy to find. And then this is the last index sheet. Just kind of wrap things up. And essentially, I think the thing I really want to focus on, we got our barrier delineator so the vehicles can see it for safety. We define that for the contractor, where to place it. As far as this deflection, Durwood was talking about setback distance, and the setback from the face, it's always measured from the face of guardrail. And so you follow this table, and if this defines how to transition post spaces. So if the designer just needs to call out begin and quarter spacing, then you realize, okay, I got quarter spacing here. Now I can be within 3'2" of a hazard, and you basically use that, and it spells it all out for the designer and the contractor. All right, well, we're getting close to our end time here. I had some other things I'll quickly show you. For those of you who can just hang in there. Basically, this is where we find our IDS, and this provides a lot of designer information, defines all the components that make up Guardrail. If you really want an education, you can really just read through it, or you read through it when you need it, and that'll be there to help you. One thing I want to talk about quickly is the length of need concept, and this is something else. Is essentially, how long does this guardrail have to be X to protect the vehicle going right to left in order to shield that hazard successfully? And so now we're using an AASHTO equation, and I realize I'm moving through this very quickly, but it's just to give you an overview so you know it exists, and if you want to learn more about it, you can go find it, or you can go to our future training, and I'll show you some information on that in a moment. Okay, so essentially you'll be using a little equation here and these variables to design the length of guardrail, and this comes from AASHTO Roadside Design Guide. We now have an Excel sheet to help with that. And here would be a quick example. the clear zone can be found in the PPM that you need, and you also you can basically interpolate the runout length from an ASHO table, and this is all done in the Excel sheet, so it shows you here. So then we run through our IDEA, shows you a lot of example configurations for shielding hazards. So we'll just basically flip through those so you know what's out there. Our length of need program would be the last part of our formal training, and that's found right here in the XLS. And so essentially you put in all these design variables, and it will tell you your station and offset at post 1 and exactly where things need to go. If you got two-way, two-lane, you need to design from the back direction, so your traffic is going left to right here. And so you put these variables in, you say, yes, I need that because we have two-lane, two-way. You say yes, put in some more variables, and then ultimately the design program gives you your station and offset for here, and exactly what you need to design the guardrail, and you're done. The same thing, we have our median crossover configuration. Few more variables to put in. A lot of them are defaults and they'll always be that way, so it's not really complicated, and it's nice as a one-step process. You put them in, you get a result. It tells you the station and offset here, 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 and here. It designs it for you. So that is the ultra abbreviated version, just to let you know it exists. Okay, real quickly, I want to let you guys know, by the end of May, we're going to put a 6-hour design webinar at this location. And so essentially what you're doing is you're going to our roadway design page, divisions, training, design update training, 2016. It's buried in there, but you can find it hunting around for a little bit. And this is where our current training that we're giving you the districts, it's basically 7 hours a day. We're going to make it about 6 hours and put up a webinar that gets a lot more into design detail. And so here's where you would find that. So I'll give you another moment. If you guys have my email address written down, if you want to know where to find this thing, just send me a quick email and I could shoot you back exactly where it's located. And so that's where you get our future training that's more in-depth and more complete. And then some of you that were interested in that guardrail training we've been giving to every district, you may have wanted to go to that, but you just weren't aware of it. So for upcoming projects, for all of our FDOT projects upcoming, you essentially sign up here, and if you want to get to it real quick, just Google FDOT contact mailer, and it's the first thing that comes up. And basically, it's this contact management, e-updates, and contact mailer. So it's really easy to register. You just put in your email address, make up a password, and then you fill out all the type of things you're interested in. And anytime the DOT has anything to say about any one of those topics, a change or new training, they send you an email on that. So, and again, it's called a contact mailer. So you'll see when your inbox, it'll say FDOT contact mailer. It'll tell you the subject. And for our last guardrail training, if you had been signed up to learn about roadway design standards, you would have been informed of that class about 5 or 6 months ago, and you could register for it. And then you might have gotten into one of those sessions, that's longer and live in person. And so that's it. That's the end of our presentation. Sorry we ran a few minutes over, but I think we gave you a good overview, if not a really fast one. Let's see. So we'll see if we have any questions.
The only question in the chat right now is about PDH credits for those upcoming sessions you're speaking of. Are they offered?
Well, the sessions are already, all the registration has already been completed. We've already visited 5 of the 8 districts, and so that's in progress, and we know that's over. Unfortunately, no one else can really get into those, but we do offer, we're going to offer that webinar that's the same thing. We're going to post that to our website. And so they can watch that. I don't think there are PDHs for watching the webinar.
Yeah, if I recall the requirements, you need to be live at the presentation in order to receive PDH.
Exactly. So, so for all of those that were able to make it into those and be registered for that class, we gave out 6 PDHs. Unfortunately, I don't think we're offering any more for Guardrail coming up in the near term. But yeah, so we're going to offer that webinar and then also offer about 2 hours in the Design Expo coming up in Daytona.
Yeah, that's a reminder. I mean, if you're looking for PDH credits, I mean, we do one of these a month, and these are free. So keep coming back to the Safety Academy.
Exactly.
Good
So
point.
yeah, sorry for running a little over. That was a lot of information.
No.
We tried to keep it real high level and breeze through.
Richard, this is Dennis. I just wanted to thank you again and Durwood very much for putting this on.
Okay.
It's very interesting, so I really appreciate this. So.
All right, thanks. Thank you guys.
There is one more.
It all set up.
One more question in the chat, if you guys have a minute. It was not covered in the webinar, but with regards to temporary crash cushions, are these the same as the permanent? There doesn't seem to be a distinction in the PPM or the design standards. Is it the same unit?
I don't believe so. I'm not, to be honest with you, I'm not the MOT engineer, and Durwood's not here, unfortunately. But I don't believe they're different. If they have a more specific the exact question on it, I can look into it and get them a better answer. So tell them just to please send me an email. I apologize.
Yeah, no, not a problem. So just
Okay.
Darren, if you can contact Durwood and Richard with an email, then they'll follow up with you.
Yeah. There should be a distinction, but I'm not familiar with the exact differences.
All right.
Okay. All right, guys. Thank you very much. I appreciate it. I think it's lunchtime for a lot of people. Okay.